Hey, I'm adding some lights to my hat here. Powered with the board, powered by the computer chip or a computer battery. And I'm going ahead and cutting up some wires so I can use them for the connection here, and going to tie them together with the LED, like that resistor and the LED together is right there. Just gonna use this lighter, heat up the wire a little bit, wait a second, and then you can pull it right off to get that plastic off of the wire. And I've done the same with the this is the long copper wire I have here. It's just actually a speaker wire that I bought in a hardware store. It's supposed to be for stereos. I don't know, it might be 14 gauge. What do they call it? Braided wire. Not solid. So I'm gonna like kind of fray them out like that and then twist them together. Do that with both ones. So for this other side, I'm going to use the wire, and this is just the other end of that wire that I just added the two pins on. So here I'm going to tie the resistor together with this this one. It doesn't need to be frayed out this time, so I'm just gonna give it like about the same length on each side there, and then try and twist them both around so that it's like kind of they're wrapping and it's not just one wrapping around the other. Do that up almost to the end. It should hold pretty good. There you go. I can bend it out of the way there. And then I'm gonna do the same with that. And the LED it doesn't matter which side the power runs through the LED, but we can just switch it over on the pin side. So unless you're wanting the colors of the pins to be a certain color, then you can just do either way. I don't remember which one's positive and which one's negative. And I like to kind of like bend it in a loop at the end to keep it from falling off. And then I'm just going to connect the LED to that end of the wire here to complete the circuit. And then I'll also bend it in the loop at the end. There we go. So we got another LED there. So you can see the effect here. We upload and then the red turns off when the yellow is on. And then we're going to add another couple of strings here. So we're going to have two on, two off, and we're going to hang them all in the front of the hat here. And you can see how the wires are hooked up. So this is the yellow, this is the red. They're connected to a ground line, and each one is powered by its own individual pin. So we got 12 and 11 powering the red and yellow. And what we needed to have an individual pin for each one. I couldn't wire them in series because the voltage would drop and the voltage would get too low. And I didn't really find a way to work around it. I tried to wire them in parallel. I couldn't get it to work for when I tried. And I was reading online, people were saying that you have to use a pin for each one to avoid the voltage drop. I guess maybe because it's only 5 volts, you have to wire them each to their own 5-volt pin. But maybe you could skip the resistor and wire them, a couple of them in series also, but having them each on their own pin allows at least us to control them, so that they can be on and off like that. But we could have all the ones that are going to be on at the same time could be wired in series perhaps. So yeah, well, that's that. So I wanted to show some of the action here. We got the red light and I got this blue one also. And you can see that when I hold the blue one up to either sides of the resistor in the correct sequence, it lights up. It actually doesn't seem to drop the red one really at all. And actually this would be a parallel wiring, wouldn't it? Because it's going across the resistor, but it's not required to go through the blue to get to the red. So I wonder how many times you could do that parallel wiring before it doesn't work. Maybe the way I was trying it before was I was trying to go on the same side of the resistor as the red, and I don't really understand why that doesn't turn it on, but you can see if I'm not across the resistor, the blue will not turn on. But if I do go on the resistor, then it does turn on. So now it's on either side. So maybe this is just because I'm not really sure, because I guess the current wants to flow only through the red one now. It doesn't want to run through maybe the resistance of the light of the blue one, I suppose. And I don't know why that would change when it's yeah, I guess when it's across the resistor, it's still the current can either flow through the resistor directly or through the blue light. So it's going through the blue and then into the red. Yeah, I'm not sure. Maybe I should make a drawing or something of it, but yeah. So I was actually able to set up another test here, and you can see like how brightly this red is shining. And then like we were doing before just now, when I connect the blue across the resistor, it doesn't seem to decrease. It doesn't seem to decrease the red really. It's just like about the same. But okay, but then when I take it and if I hook it, so this is the connection for the red here. If I unplug that and then plug the blue in and make the current flow through the blue to get to the red, then now you can see that they both got a little bit dimmer. So you see that, and I think the way I just touched it now allows me to do it one at a time. So here we can see how bright the red one is when it's just red. Now if we connect to blue as well, you can see that I believe they're dimming a little bit. So that's just red. That's blue and red. A little bit dimmer, I think. So, and that was also true when we had the blue connected in parallel. It was not really dimming the red in the same kind of way that last one was. Like you see, when I add the blue, it doesn't seem to lower the red much. So I'm going to go ahead and add this blue or this red wire onto the hat now. I'm kind of just snaking it through the hat band and going along like that, looping it once or twice here. And probably should have started the other direction actually. Okay, so we got the front going down out through the the top of that hat band there. And we tighten it up. And then we got two little lights now. Looks pretty cool. Let's try and turn the lights down. See how it looks. Yeah, not bad. Let's see if I'm debating on whether to have them up on the top there like that, or to have them dangling down over the front. I feel like actually maybe over the front looks cooler. I'm trying to learn how to read this resistor bands correctly, and I'm pretty sure that I should start from the red side, because that would mean 2 2, so red black brown, so that would be 2 2 0 multiplier 1 brown tolerance 1%, which makes more sense than if it was the other direction. You know, if you flipped it, then it would be brown black red, and that doesn't really make sense, because then it would be brown black. It would be 100, and then the multiplier would also be 100. So it wouldn't really make sense for them to have that confusing of a multiplication when it could be written in such a simpler way for 100 times 100. You know, it would make more sense for them to do, like, you know, I don't know, less bands, and just do like 1 times 10,000 or something. So we can take a look at the code here, and each LED corresponds to a pin. So the yellow one was 12. We're gonna go and do 11 next, and I already wrote it here. And the way we're gonna do it is that they're gonna switch off. Every odd number is going to go low when the other one goes high. So you can see here how I have them grouped. High, low, high, these are gonna be off, and then it's gonna delay for a second, and that's going to give the switch effect for that red LED. Go looking a little more buttoned up with these lights tucked in up there. Might be nice that way. I'm gonna speed this animation up a little bit. Can actually, yeah, I'm just gonna set these both to like 200. See how much of a seizure that is going to give me. All right, we got it uploading. Getting ready, and oh, there we go. That's a lot faster. Looks like a police car. I think we should be able to control these since they're all individually done. So we could even do 1 2 3 from right to left. Let's try that. So this is what the code looked like in Git. I'm showing you in Git just because that's, yeah, it's there. I had first the number 12 is on, it pauses, and then the 11 is on, it pauses, and then the 10 is on. So that gives it that left to right animation. There we go, it worked. First try. Got it going left to right or whatever. Pretty cool. Could add some more of those and make it go all the way around. Hey, so I had this formula here that I've been trying to use in the code. So actually, dial it back. What I was trying to do here was to get the lights to do the left to right flash, but first to speed up. So it starts it starts 1 2 3, and then it goes 1 2 3 1 2 3 1 2 3, and it like speeds up like that. And then I want it to slow down again. So I got it to speed up, and now I'm about to get it to slow down too by using this like complicated looking function. But I think just adding this negative here is going to fix it actually. Hey, I got this hat that I added some lights on, connected each one to an individual pin on the Arduino, and I made a little loop to make the lights go on and off kind of the speed changes. First they go slow, and then they go faster and faster. Faster, faster, faster. There you go. And then they slow down again. It's like a for loop. Goes up to 10, and then it slows down after 10 up to 20. So yeah, little light hat.